yesterday we did basic simplifying, adding, subtracting, multiplying, and then today, dividing radicals. All right. You ready for number one? No? Okay. You're just being sarcastic. All right, number one. You're ready, I can tell. Square root of 5 divided by 8. So the first thing I would do is when you have a fraction like this, go ahead and split it up. So you can rewrite this with the square root of 5 over a square root of 8. And it's not necessary that you do that, but sometimes visually it's just easier to see. So when we're doing radicals with division, we never want to leave a radical in the bottom. Never leave radical in the denominator. So it's kind of like when you're simplifying, this is part of simplifying. You don't ever want to leave radicals in the denominator. So we're going to get rid of the radical in the denominator. So in order to do that, I need to come up with a perfect square. So what I'm going to do is do kind of a box here. I need to come up with a perfect square on the bottom here, because if it's a perfect square, I can get rid of my square root. So here I have 8. What can I multiply by 8 to make this a perfect square? I can do 8. Okay. So if I multiply by an 8, I have to do square root of 8 over square root of 8. Now, why did you choose 8? 8 times 8 is 64. What's the square root of 64? 8. Okay, the reason you have to do one or the other is because this is the same as multiplying by a 1. Because you're putting something into this expression, you can't just put like a 1 over square root of 8. This reduces to 1, and so you can put anything in as long as it's the same thing on top as it is on bottom. Okay, if you didn't have to do 8, I could also do a lower perfect square, so I could have done 16. What would I have multiplied by to get 16? Yeah, you could do square root of 2, but it doesn't matter. Okay, so we multiplied across the bottom. Square root of 8 times square root of 8 is 64. Square root of 5 times square root of 8 is square root 40. Now we have to simplify that square root 40. So what perfect square is inside 40? 4, so 4 times 10. So same thing we did before, bring this 2 out. So I have 2 square root 10 over 8. Can I simplify anything? Do I simplify the 2 and the 8, the 10 and the 8, or all of them? Good, the 2 and the 8. So that reduces to 1/4. So my final answer, square root 10 over 4. Okay, so what you're looking for is a perfect square on the bottom. That way it goes away. So you just have to multiply by something to get that perfect square. So let's try another one. Where's my number 2 there? Square root 8 over 3. Okay, so I like to split it up first. Square root of 8 over square root of 3. Okay, we have to multiply by something to get a perfect square on the bottom. Square root of 3, perfect. Okay, you can always multiply it by itself for perfect squares. Like if you have a 5, multiply by a 5, you get 25. So in this case, multiply by a 3, that's going to give us 9 on the bottom, which is a perfect square. What do I get on top? Square root of 24. So on the top, if I I break this apart, we get, what, 4 times 6? And on the bottom, we have a 3. Okay, so I'll pull out the 2 from the 4. 6 stays on the inside, and 3 on the denominator. Not horrible, right? Okay. And it doesn't really get that much worse. I mean, it'll move away from just single numbers like right now, but it's not bad. Okay, number 3. 6 divided by 4 plus the square root of 2. So when it's a single number like 1 and 2, you multiply by some other single number. Here, I'm going to multiply by what we call the conjugate. And I'm going to write that right here. The conjugate. So the conjugate just means you take the bottom and I'm going to flip the sign in the middle. So I'm going to multiply by 4 minus square root 2 over 4 minus square root 2. That's called the conjugate, when you just change the sign in the middle. And we'll talk more about that too next week. We do conjugates of imaginary numbers. I know, crazy. It's not bad though. Okay, so on the top, I have 6 times a binomial. So I'm just going to distribute the 6. So distribute the 6. So on the top here, I get 24 minus 6 square root 2. Okay, on the bottom, how would you multiply that out? FOIL. Now what's nice about this, let's go ahead and FOIL this. So if I FOIL this, I would get 16, 4 times 4, and then I would get negative 4 square root 2. Then I get positive 4 square root 2 minus square root of 4. What happens to the middle terms? They cancel, and that's what's nice about conjugates, is when you multiply the 2 binomials together, really we're going to start taking the shortcut of just multiplying the first 2 together and the second 2 together. So here, underneath on the bottom part, I have 16 minus square root of 4 is 2. So it's only when you multiply conjugates together that you can multiply just the first terms and the second terms. It makes your life a little bit easier. So if I simplify this, 24 minus 6 square root 2 over 14. You always want to wait to simplify until you get to the very end, and then you look at all 3 numbers. So I look at what can I take out of 24, 6, and 14. 2. So this is going to become 12, 3, and 7. It has to come out of all 3. If you can only take it out of like these 2, then usually we'll just leave it. So my final answer, 12 minus 3 square root 2 over 7. Any questions on that one? It's not that bad. Okay, let's do another one like that. Number 4. Square root 5 over square root 2 plus 3. So I have a binomial on the bottom, so what do I multiply by? Square root 2 minus 3. That's the conjugate. So on the top, you're just going to distribute because you only have one term. So distribute gives us, what, square root 10 minus 3 square root 5 over. So here's the shortcut. When I do the conjugates, multiply the first 2 together. What would that give me? Square root 4. You can write square root 4 and then simplify, or you can just write 2. Square root 2 times square root 2 is square root 4, which is 2. And then I multiply the second 2 together, minus 9, or negative 9. And then simplify. So square root 10 minus 3 square root 5 over negative 7. Can I simplify that at all? No, it's done. Okay, number 5. So this is really the most complicated it will get, is that now we'll have a binomial on top and a binomial on bottom. So if nothing changes though, you still multiply by the conjugate. So go ahead and put the conjugate next to it and multiply it out. And let's see what you get. So what is the conjugate? 4 minus square root of 3. And sometimes I see people just moving too fast and they do the subtraction of the top. We don't care about the top, we care about the bottom. So the bottom you can do your little shortcut, the top you still have to FOIL. Done. Check through the time. Questions on 5? Somebody still writing anything? If you're done with 5, I want you to do this last one like this, number 6. Be really careful because there's a lot of radicals. So just make sure you multiply the correct things together. So if you're still working on number 5, it's fine, but then I want you to work on number 6. There's just a lot of radicals, so just be careful. It's not horrible, just... the top, and then I did the conjugate on the bottom. I left all my radicals, that way if you get confused, you can see where I'm getting all my numbers from. Do you guys have questions, or did you get it? This is your final answer, 4 minus square root 10. Got it? See, it's not horrible. I would really just be careful when you multiply out your radicals. Anybody needs to see if they went wrong somewhere? I see some people got it, that's awesome. I just got Christmas stickers. Nick, all those on Christmas. I know, I remember Thanksgiving after Christmas. Okay, is anyone still on number 6? We have a few more that's not like this. Anyone writing? Okay. Yeah, so what I did, like I foiled, so I did this times this to root 25. You can only do radicals that are, like you can multiply under the radicals together. Yeah. And then, so I did 2 times this root 2. That's where I got this 2 and then the 10 on the underneath. And then here I did the same. I distributed, so I got root 10. And then I distributed, I got root 4. So then here, this one, my other class was like, where did that 10 come from? Because this is 2 times 5. The square root of 25 is 5. And then 2 times 5 is 10. So that's that. I combined these two together. It was a negative 2 and then minus a 1. Negative 3. Square root of 4 is 2. And then I just combine like terms. So 10 plus 2 is 12. 5 minus 2 is 3. And then you say, well, can I take out anything from all 3 of these? And I can take out 3 out. So that's it. Okay, so the last part is kind of like the first 2 we did, only instead of a square root, we have some that are going to be like cube roots or 4th roots. What number are we on? 7. Number 7, cube root of 5 over 4. Bless you. Okay, when we did square roots, we looked for something to multiply this by to be a perfect square, right? So like we did, what, an 8 to get square root 64? Well, now instead of perfect squares, I need perfect cubes. So we don't have very many cubes, which is kind of nice. So I need to multiply something by this 4. If you want to split it up first, I didn't do that. So I need to multiply something by this to get myself a perfect cube. 2, right, because 2 would give us 8, which is a perfect cube. So I multiply by cube root of 2 over cube root of 2. So I get cube root of 10 on top and cube root of 8 on bottom. Can I simplify the top? No. So cube root of 10. And what is the cube root of 8? 2. Can I reduce this? No, you can't. That's it. That's what's nice about your cubes and your 4s, because they don't simplify very much. This 2 or this 2? This one. Cube root of 8, so that's under the S right there where it says 2 cubed is 8. Okay, number 8, let's do a 4th one. 4th root of 3 over 8. So I'll go ahead and split it up. So I'm looking for something to multiply by to get a perfect 4th root or 4. I figure out there's a word for that. So multiply by 8, that would give me multiply by 2 would give me 16.
Oh, I was looking at that.
That's okay. I was too. So multiply by fourth root of 2. Right? Okay. To give us a fourth root of 16. And on top, what do we have? 6. So I can't do anything to the top. And fourth root of 16 is 2. Make sure you're kind of working. I would at night take like 5 minutes, maybe just 2 minutes, and just try and do your squares, your cubes, and your fours. Because remember, you don't get a calculator, and those will not be up there for you. Last one, just one with numbers, or sorry, letters. We've already done numbers. Last one, cube root of a squared over b. And I'm going to break it up first. So we have, they gave us cube root of b. What would have to be under here for me to be able to take it out of there? B, okay. B cubed, but are you saying multiply by b squared? Okay, you just added. That's fine. Yeah, so I need, what I was trying to say is, this is what we have. I need it to be this, because then I can divide evenly. So I have 1, I need 3, so I need 2 more. So I need this to be cube root of b squared. Cube root of b squared. So across the top just becomes a squared, b squared underneath. Across the bottom, cube root of b to the third. Can I simplify anything on the top? No. So just leave it. Oh my gosh. A2, B2. And on bottom, I get the B. Okay, so I want you have 15 minutes left. I want you to use that 15 minutes to either work on yesterday's worksheet, which is the one that's for a grade, due Friday,